Good evening. I'm Emily Ferfaro with NASA's Office of Communication, and I'm here at the Lunar and Planetary Institute in Houston, Texas. And I'm joined by Rick Davis, Assistant Director for Science and Exploration at NASA, Ben Busey, Chief Exploration Scientist at NASA, and Alex Longo, one of the landing site proposal team members. So we are here, and we're taking your questions from social media all about Mars and landing sites on the Martian surface. And if you have questions, use hashtag AskNASA, and we'll try to get to as many as we can. So I will go ahead and ask the first question. We've gotten this from quite a few people on social media, and they're just curious. So NASA's plan is to send humans to Mars in the 2030s, and that's sort of a long time from now. So why start the site search now?
Okay, so there are a couple of aspects to that answer. The first is that NASA currently has several spacecraft in orbit around Mars that have been there quite a while and won't last forever. So part of the idea of looking about where on Mars is interesting for future human exploration is we would like to use those assets to take pictures now while they're still working and healthy. And the other part of the answer is while the plan is to send people in the 2030s, it's very likely that we will want to send precursor landers to Mars well ahead of that time to in place infrastructure, to test capabilities. And so when we do that, we'd like to send that to the location. So we need the date much sooner than the 2030s.
And if I might.
Yeah.
So one thing I would add to that too is that I think even as a result of this process, we're learning that there's things that we are probably not going to be able to find out about Mars with our current fleet of satellites at the planet. And so this process, and it's already, you're seeing it in the discussions today, is already sort of informing what those next generation satellites are going to have to be. The current Mars Reconnaissance Orbiter that's there, right, observatory that's there, is I believe 10, maybe 12 years old at this point, and it's basically beyond its design lifetime, which is one of the reasons why has been pointed out we want to use it, but we also need to figure out what comes after it so that we can actually really ultimately pick a landing site.
Part of it's also that space exploration doesn't happen overnight. Big things like going to the moon or building a space station or landing people on Mars take decades of work, not years, decades. And part of it also is that there are scientists and engineers spread across the country working on this, and the public's really interested in landing people on Mars as well. But we need to get all of that interest in this one goal consolidated into one place and have people actually start talking about what we're going to need, what sort of capabilities are we going to have, and where are we going to go.
Great, thank you. That was awesome. Next question. What are the top 3 things or so that you're looking for when considering potential future landing sites on Mars?
So I think one of the key aspects is going to be, is obviously safety is paramount. We want to make sure that the region that we go to is safe for landing the crew. And then once we've got them safely on the surface, we expect them to have a lot of mobility, to have a pressurized rover, and be able, right now we're assuming they can go roughly 100 kilometers or 60 miles. So we're looking for a diverse selection of interesting science locations for them to visit. And also, the goal is to go to Mars in a sustained way, and to do that, you don't want to take everything with you from Earth. The more you can live off the land, the easier it is to do. So we're also looking for regions that have resources that we might be able to make use of, particularly water in various forms.
The only thing I would maybe add to what Ben said is that we really, he mentioned the word sustain, but really what we're talking about is essentially a base that we send multiple crews to. And so we're going to build up supplies, we're going to build up spares, parts, all that kind of stuff, so that people really have options when things break, for example. And so that becomes even more important to have the resources, for example, so you can live off the land, or to have a lot of interesting science and diverse science things to go do, because we're really talking about a long-term commitment.
Great. And this kind of stems off of that. This just came in from Twitter from Kevin Stevens, and he wants to know, how do you balance what's scientifically interesting with what's safest for the crew?
Well, safety is always paramount. We're talking about human lives here, and the first mission, we don't really want to take any unnecessary risks. The good news is that the zones we're considering for landing in are only about 100 by 100 meters, which is really small compared to what we can achieve with a robotic rover. So even in a really rocky, really steep place, chances are in this 200-kilometer diameter circle, there's going to be somewhere safe you can put the astronauts down. Now, part of it also is slopes and finding places where they can drive their rovers and identifying hazards like radiation and such, and work's ongoing on that.
Great, thank you. This one's specifically for Alex.
Okay.
You're from Raleigh, North Carolina. First, what school did you go to, and are there a lot of students at your school who are interested in science and Mars?
Well, I just graduated from the Montessori School of Raleigh last year, and that's honestly going there for 7 years was how I learned to voice my opinions, speak in public, make a well-rounded argument that's rational. That's really how I got where I am today. Currently, I go to the Cardinal Gibbons High School. I just started this year, and I was completely surprised by how much interest there was in space. I started a space club there, not really expecting many people to join. It turns out we've had 3 meetings. We now have 30 members.
Wow.
So space is popular, and really just part of the challenge is harnessing all of that interest in space from all sorts of people.
Great, great. Okay, the next question, what will future human explorers do once they arrive to the Red Planet?
So the current the current plan is for once the crews get there, they're likely to spend several hundred days there before coming home. So, as in the previous question, the goal is to try and find a multitude of interesting science to do. But also, I mean, we had Stan Love, a current astronaut, talk to us, and he explained to the audience, it's very interesting, that they've done analyses that on a given 24-hour day, you know, you've got 8 hours of sleep, you've got a certain number of hours that you spend, in the case of space station, keeping station operating, and that, you know, you probably might only have a handful of hours each day of time to be doing if you like, pure science. So that will be a factor. But to come, I guess, with the question, I mean, they'll spend some times in the main habitat. The hope is that there would be science analysis equipment. It's always, the scientists will be very keen on the samples that get brought back. So one of the activities that we can imagine the astronauts doing is doing some basic analyses of those rocks, because they won't be able to bring back to Earth all the ones that they collect on Mars. And if you like, high grading, trying to work out, collaborating with scientists back on Earth to work out which rocks to come back, as well as going out in the field to collect those rocks and do other studies.
If I might, so I work in the Science Mission Directorate, and you know, we've had the first orbiter around Mars is literally 50 years ago, and we've done tremendous things with the rovers. But when you go out into the science community, it's actually pretty amazing in terms of how much people have really come to the conclusion that we're ready for the next big leap, which is actually having a human being there who can really, when they see something really cool, they can react to it and do something immediately with a laboratory there, and we're really at that point. And you know, so for example, with the rover, it's really incredible. If you go out to California where they manage the rovers, you know, it can take like up to 22 minutes to send a command to Mars. And then if you want to make sure it got coming back, then you got the same time to coming back. So it can take a long time to do it. It's anywhere from 7 to 22 minutes. And so having a people there, or they're actually making decisions right there and running robots or whatever, is really incredibly powerful. And we will be able to make orders of magnitude increases in terms of the science and the other things that we can do once we get people there.
I think from hopefully a future astronaut's perspective that, well, imagine that you're an astronaut for a minute and your lanter's just set down on another planet for the first time in history. You get up, you look out the window, and you see this red landscape. There might be a valley in the distance or a crater or some sort of mountain, and it's totally alien. It's nothing like the Earth. You might see some features that have some resemblance, but overall it'll be totally different. And then you open up the hatch to your lander, you step out, you go down the ladder just like Neil Armstrong. You plant your foot in the soil, one small step for man, one giant leap for mankind. And then you start exploring this environment that really no one has ever been to before. It's true exploration. Just like when early settlers came to America or when the Apollo astronauts went to the moon. Really, there's just nothing truly like that. And I think everyone who is alive at that moment will remember it. The whole world will be watching the first human footsteps on Mars.
Yeah, definitely. It's very exciting. Here's another question, sort of a planetary protection question that we got on Twitter. And they ask, what's the process for in-space sterilization so that we know we're not bringing things from Earth to Mars or other planets?
Okay, so that's a great question. So basically there's two big concerns. We're trying to find if there's life on other worlds. That's a big part of the research goals that we have. And so it doesn't really do any good if we take it and pollute it with our own microbes. So that there's that goal to protect it. So that's one part. The other part of it is you don't want to be bringing back the plague. In terms of microbes, I'm being a little facetious, but that actually is the core idea, which is that we don't want to be infecting the astronauts together or having those astronauts bring something back to the Earth that is really dangerous for here. So part of that is understanding more about Mars. Part of that is trying to get samples back from Mars in a controlled fashion so that we can actually make sure it's safe. At some point, you have to accept the risks too. You can't stop doing exploration just because you haven't been able to check the square. But you do due diligence, and that's what some of these steps I just described are trying to do to protect us. And then even there's still going to be some unknowns, but we'll work it hard and we'll figure out a way.
Great. This question just came in from Twitter. I really like it. Josh asks, what's the most tangible way exploring Mars helps us to understand our own planet?
Well, Mars is sort of like a fossil. It's a planet that used to be warm and wet, just like the Earth, but then everything sort of went downhill from there. Today, Mars is more like a desert, only it's a desert more hostile than any desert we'd find on our own planet. So we can take a look at Mars. We can see how it formed. We can take a look at this like pristine fossil of a planet. And then we can see how it went wrong in order to be able to better protect ourselves and make informed decisions about our environment.
So if I might.
Yeah.
We have one data point that we know. It's one planet. You usually don't make theories based off one data point. So what I mean is, just to amplify what Alex is saying, is that having access to a whole nother planet and being able to do real research on it and figure out how its weather systems work, how everything works there, will teach us, it will give us that's another data point that will really help us to understand our home planet. And the other thing which I would say is that Alex kind of talked about living on Mars is hard. I mean, it is. I kind of joke with people sometimes, with our current level of technology, it is a planet that's trying to kill you. And so we'll learn how to master it, just like we learned how to master Virginia or any of the other places, in the old western frontiers. Of that, I'm convinced. But the problem is we'll have to learn to build life support systems that are really efficient, and all that stuff will come right back to our homes, so that when you run an air conditioner in there, you're not bringing the grid down. It'll actually be a largely self-sufficient home, because that's what we're going to have on Mars. And so it's a two-way transfer of knowledge that we're going to get. It's going to really be pretty amazing.
Yeah, totally. If you look at a modern emergency room in a hospital, really a lot of the technology we've got, CAT scans, cell phones, lots of medical devices, guess where that all came from? It came from the Apollo moon program. Same thing with the space station program. We aren't really seeing the benefits of that quite yet because the technology is still under development. But 10 or 20 years in the future, our lives are going to be dramatically improved by the space station. And same thing with a mission to Mars.
Yeah. You get lots of people now, you get the hardcore sports people, they track all their medical stuff remotely. I believe it's correct to say the first ever remote monitoring of someone's vitals was Project Mercury. It'd never been done before, and that all fed straight into that field.
Yeah, that's a great point. Okay, I have another question. Are all of the landing sites discussed at the workshop in the same area or hemisphere, or are they located all around the planet?
So I'll start. So they're actually all over the planet. In fact, they are proposals literally from all over our planet, which is kind of cool. In fact, we had a Russian or Ukrainian tie-in today with a proposal, which was really exciting to see. I would say a lot of them tend to be kind of down to the lower latitudes or down near the equator. That's because that's where the rovers have been going. But what's exciting is that we're seeing a bunch of them now that are actually up in where the old oceans of Mars used to be, and we think there's lots of ice up there. And so that's like essentially new territory. And so tomorrow we're actually going to be starting into those sites. I think we're going to find out there's a lot we don't know. But that's actually part of figuring out the answers, figuring out what you don't know, and then starting figuring out what you have to go to do to figure it out. But the fact that there's ice there is pretty exciting.
So right now, we've tried to make it as open as possible for the people proposing sites. We only really have two preliminary constraints, which is there's a latitude constraint, because if you're at very high latitudes, there are some issues with if you're using solar energy with sun, it's harder to leave the planet. You need a stronger engine, and also there's an elevation aspect, which is the lower you are, potentially the easier it is to do your entry, descent, and landing. But we've tried to keep those constraints to a minimum, so they have got the vast majority of the planet to propose.
Great. Okay, this question is interesting. This person is from Twitter, and they say, our astronomy professor insists that there's already flowing water on Mars, but I thought NASA only found traces. Who's right?
Oh, I can do either way.
So yes, it's always got to be very careful to tell your professor that he or she is wrong. That does not typically lead to an A. So I would say that you could ask the political question and see what they mean by the term flowing. I mean, there are these evidence with these for the recurring slope lineae that you have at least some sort of a liquid very close to the surface. It comes and goes. That's probably what the professor is referring to. I would probably suggest smile and nodding.
Do you think, so I guess like a follow-up to that is, do you think that we'll target areas like that for future humans to go to the sites like that where there's the water?
I think that's one of the interesting things that we're starting the process of discussing now. In the recurring slope lineae, they're on fairly steep slopes, so that there can be a safety factor or an ease of excavation. We're also looking at, fairly flat regions of hydrated minerals, potentially buried ice deposits, which you'd have to dig up, but that might be more straightforward. It's too early to say. One of the interesting things about Mars is that there's water there in many different forms, and part of what we've begun, to discuss today and yesterday is going to lead to what is the best form of water to use for the future crews.
And also possibly you could have multiple sources. I mean, you could have some sort of ice. You could have this flowing water that made big news when it was recently detected. And you could also have some minerals like clay or something that has sort of water trapped inside it. And you could have all three of those in your human landing site for like redundancy in sources, just in case something goes wrong with one.
And so there's part of the things that we have to kind of balance is that, getting the water, and making it so human beings can drink it or use it for propellant or whatever, is you have to sort of figure out how much energy that takes. I mean, we don't have a big grid there. We'll probably just have solar cells for a long time, which means you're inherently limited. And space station's even limited on how much power it can generate. And that's going to be the case. And so we have to kind of figure out what we can do and where it is and how much energy it takes to get it freed up. And that's part of the fun of trying to figure all this out.
Great. Okay. Another question that we have is, so once these site proposals are reviewed, what are the next steps?
I think the most important next step to come out of this meeting is dialogue, is what we're doing. We have the scientific community, we have the resource community, and we have sort of the civil engineering communities all together, I think, for the first time at a meeting such as this. So people are, people who are very good in their own field are meeting people who are very good in other fields. And I think getting them talking to each other and working together on analyses of these exploration zones, to me, is the most important thing that will come out of this.
Great. Okay, I have a couple rapid fire questions,
Sure.
just 5 that are really fun. So we'll try them out. So, all right, what is your favorite sci-fi movie? And it doesn't have to deal with Mars.
Apollo 13.
Okay.
Mine's The Martian. I'll take that one.
Serenity.
All right, great. If you could solve one Mars mystery, what would it be?
Life on Mars.
Oh, that's a good
Might have
one.
stolen it.
I would want to know exactly where the water is.
How we send people there.
Yeah. Mars bar or Milky Way?
Mars bar.
Mars bar.
Yeah, Mars. Bar.
Okay. If you could travel back in time to any historic space event, what would it be?
I'll go with first space shuttle launch.
That's a good one.
Well, mine is actually what we're doing right now. I think what we are doing is paving the way for something really cool, and I wouldn't want to go back to any of the others.
I'd like to Apollo 11.
All right, the last one I have. What's your elevator pitch for why people should be excited about NASA working to send humans to Mars in the future?
We are exploring the unknown. And we've picked Earth over in detail. Yeah, there's still some stuff left to explore, but this really is the next frontier. If you want to go out there and just find something really cool, no matter what your experience level is, and have a chance of doing that, then I'd say that looking at space is the way to go. It's a human desire in our genes to explore, and I think it's vital that we continue that as we expand through the solar system, and eventually to other stars hundreds of years from now.
What he said.
I totally agree with what Alex said. I would even add that we're incredibly lucky to be living right now. We're on the verge of becoming a multiplanetary species. And on Mars we actually have a chance for self-sufficiency. It is very difficult with any of the other planets or moons in this solar system to do that, and we are extremely close to doing that. Now, I'm not trying to trivialize how hard it is, because it is hard. But when I see the kind of creativity that was in this room today, I am absolutely convinced we can get there if we, with a lot of hard work.
Totally. Actually, I'd like to share a phrase that sort of has become my motto, and it's from an earlier NASA mission: "If it isn't impossible, it isn't worth doing." And I think that if you follow that philosophy, you will go far in life. Just don't write something off as impossible, because in reality it probably can be done just with a lot of hard work.
That's a great point. Well, that's all the questions I have. Thank you very, very much for joining me this evening. Thank you very much for submitting your questions, and more proposals will be discussed tomorrow, and you can watch live on Ustream starting at 9 a.m. Eastern Time. Thank you very much.